Okay, Precast students, in this video we will be looking at quite a few different topics. They're going to be little quick topics, not difficult. So instead of giving you just one heading today, I'm going to give you a bunch of little headings throughout the entire video, okay? So with that in mind, let's go ahead and get started. Please copy down your first heading here. Let me turn off my cell phone. All right, there we go. And go ahead and copy down this first heading if you would, please. Dot products. Okay, now what we're going to do today, and I should have mentioned this up here in the introductional sentence there, is we're going to take our vector studies a little further today. Okay, so we're going to start off by looking at dot products of vectors. Now, all of the little headings we're going to have today are either from lesson 13.3 or 13.4. So I'm not going to differentiate between the two. We're kind of doing a little conglomeration and combination of the two lessons. Okay, so I'm not going to put that up here every time, but understand we're going to go back and forth between 13.3 and 13.4. Okay, so your first heading today is dot products, and we're going to look at how to find the dot products. By the way, let me say this. I mentioned earlier we're going to look at a lot of little topics today. Understand they're pretty easy and they're little topics, but they're very important. We're going to apply a lot of these later on when we start doing some word problems with vectors. Okay, so it's really important you understand all of this little stuff. Okay, all right, let's go ahead and continue on. Now, when you multiply two vectors, and by the way, when we multiply two vectors, we call that dot product. Okay, so when we multiply two vectors, you would think that you would get out another vector. That would make sense, but you don't. Okay, you do not. You get out a number. Okay, so when you multiply two vectors together, when you take the dot product of two vectors, you don't get out a number, you don't get out a vector, you get out a number. Let me demonstrate, okay? Go ahead and copy these vectors in your notes. Okay, vector u, vector v, and vector w. Go ahead and copy these vectors in your notes. And I'll wait just a second while you guys do that. And then we're going to take u times v, v times w, and u times w, okay? And you might be thinking, Mr. Arrow, we did this the other day. We took like 2u. And now that's true, but that's not a vector times a vector. That's a scalar. That's what we call that number. It's a scalar times a vector, okay? And when you do that, you do get out another vector, okay? But in this case here, we're multiplying two vectors times each other, and we call this the dot product, okay? So here we go. Hopefully you've copied all this down. Let's first of all find the dot product of u and v. Now, after I do this first one, if you want to work the next two on your own and work ahead of me, that's totally fine. Just make sure you're keeping an eye up here to make sure you're doing the problems correctly, okay? So here we go. U times v. So here's vector u, 2, negative 5. And here's v, 0, 4. Okay? Now here's what you do. You multiply the first number times the first number. It's so easy. 0. Multiply the second number times the second number. Negative 20. And then you add those two numbers together. That's it. It's so easy, okay? So there's the dot product of u and v, negative 20. Okay? Pretty simple. Very simple, to be honest with you, okay? Very simple. Okay, you can work ahead or watch me as I do the next two problems here. All right, here we go. Okay, vector v is 0, 4, and vector w is negative 3, 1. And there we go. Okay, so let's go ahead and multiply these together. 0 times negative 3 is 0. 4 times 1 is 4. And we add those two together, so the dot product of v and w would simply be 4. Okay? Hope I'm not going too fast on this. You guys are probably enjoying this. It's pretty simple, so not too difficult. Okay, the dot product of u and w. Alright, here we go. Vector u is 2, negative 5, and vector w is negative 3, 1. Okay? Hopefully I copied those correctly. Here we go. 2 times negative 3 is negative 6. Negative 5 times 1 is negative 5. And we're going to add those two together, okay? A negative 6 plus a negative 5. So the dot product of u and w would be negative 11. Okay? So make sure you can do these pretty quickly. They're easy. Make sure you know how to do these quickly. So when we get into problems later, we're actually going to use some formulas where we say that you take the dot product of two vectors, so you should be able to know how to do this pretty quickly so you can use the formulas very quickly, okay? Alright, let's continue on. Okay, another heading today. And remember, I'm not going to keep telling you this, but if you want to put a lesson number, this is not the right lesson number, okay? I've used some of these slides in previous books in the past, okay? And so remember, it's lessons 13.3 and 13.4 today, okay? Alright, unit vectors. Let's take a look now at a topic called unit vectors, okay? Copy that down, please, unit vectors, and be sure and include today's date. I hope you're doing that, or at least once. Hopefully back here, this heading here, hopefully you included the date back here, okay? At least one time in your notes. Okay, unit vectors, here we go. A unit vector is a vector that has a magnitude or length of 1. That's it. So when you draw the vector, it has a length of 1. So any vector that has a length of 1 is called a unit vector. Alright? Now, here is an example of a unit vector. Let me prove that to you real quick, okay? Copy this in your notes. Here's an example of a unit vector, okay? Let me show you real quick, okay? You go over -3/5 and then go up 4/5, about right here, okay? So there's the vector. Now, I'm going to show you how I know that we have a length of 1. Remember how to do this? You square this number, and that would be 9/25, plus you square this number, that would be 16/25. Take the square root of it. 9/25 plus 16/25 would be 25/25. And of course, anything over itself is 1, and the square root of 1 is 1. Okay, so there we go. This is a unit vector because its magnitude or length was 1. So students, it should be pretty easy to see how or when we have a unit vector, okay? A unit vector is just simply when we have a vector that has a length of 1, okay? Now, let's continue on. Not sure why that's there. Hold on one second. Okay, here we go. Now let's take a second and let's learn how to write a unit vector that's going in a certain direction, okay? Write this down. Let's say we have this vector right here, -3, 5, okay? Let's say we have that vector there. I want you to find a unit vector that is going the exact same direction. Okay, so copy this down and let's take some really good notes. Now, usually when I ask you to do this, you will not have to get a picture of this, but for this problem, I want you to get a picture of what we're doing here. So, go ahead and graph this vector. All right. So we know the vector is over 3 and up 5. Okay, there we go. So here's my vector right here. Okay. Now, here's what it means. Listen to me carefully, students. Here's what it means when it says find a unit vector that is going the same direction as this vector here. All that it means is they want to know how far up this vector you have to go until you come to a length of 1. And then once you find that place, you want to find that ordered pair right there. That's all they're asking you, okay? So it sounds pretty simple, and it really is pretty simple. So whenever we say to find a unit vector that's going in this direction here of another vector, it just simply means how far up this vector here would you go until you had a length of 1 for your vector, okay? Now it's really pretty easy to do. We're going to go ahead and call this vector here u, okay? We're going to call this u. And here's what we're going to do. There's a formula we use that helps us write unit vectors. Write this down, please. There's a formula that we use, and here it is, okay? It's vector u, okay, divided by the magnitude of u. Now I've noticed in most books that I've used, we use this for magnitude. I noticed in y'all's textbook that they're using 2 lines like this for magnitude, and that's totally fine, okay? So either way, we'll stick with this since that's what your book seems to be using. But in order to find a unit vector going the direction of this vector here, you simply take your vector that you're given, which is negative 3, 5, and you divide it by the magnitude. And that totally makes sense. That would give you a unit vector of 1. Okay? So let's go ahead and find the magnitude of u. Alright, so here we go. The magnitude of u. Well, we square the 3, that's 9. We square the 5, that's 25. We add them together, and there we go. Just like that, we have the magnitude of u. Okay? So here's our formula. So we have vector u up top. Of course, vector u up top is negative 3, 5 divided by the magnitude of u, and the magnitude of u is the square root of 34. So what you do is you take each number and divide it by the square root of 34. So the unit vector would look like this. Negative 3 over the square root of 34, comma, 5 over the square root of 34. And there you go. Trust me, students, if you were to find the magnitude of this vector right here, it would have a length of what? 1. This is a unit vector that's going in the same direction as this vector here. Okay? Now, usually I'd like you to rationalize your denominators when you have square roots. I'm not going to make you do that when it comes to unit vectors, okay? So be thankful for that and don't worry about that when it comes to unit vectors, okay? All right, moving on. Go ahead and try this on your own, or you can stay with me, okay? And there's no need, students, on this problem here to draw a picture of it like we did over here. That's not necessary. We have a formula now, and so we can go ahead and use our formula. Find a unit vector going the same direction as 3, 4. Okay, here we go. Here's our formula. First of all, let's call this vector v, okay? Let's call it vector v. Let's go ahead and find the magnitude of v. Okay, the magnitude of v would be the square root of 9 plus 16. Square the 3, square the 4. So square root of 25. This is pretty nice here. This is 5, a whole number, okay? There's my magnitude. Okay, now to find a unit vector, our formula is whatever vector we're dealing with. In this case, it's v, so vector v over the magnitude of v. So I would have 3, 4. There's vector v right here, 3, 4, divided by the magnitude of v, which is 5. So here's my answer, 3/5, comma, 4/5. And there we go, okay? This is a unit vector. If you were to find the length of this vector, it would be 1. And this is a vector, a unit vector that's going in the same direction as this vector here. All right? Now, let's go ahead and jump on to another topic here. Hopefully I didn't go too fast through this, okay? I thought about giving you guys one more example here, but I feel like this is enough, okay? So we're going to go ahead and continue on, but you should be able to, so far, you should be able to find the dot product of two vectors. You should be able to understand what a unit vector is, okay? And then find a unit vector going in a certain direction, okay? All right, moving on. Now I want you to learn to write vectors as a linear combination. Of course, again, the lesson number is not 7.6. And you do not need to write these lesson numbers over and over unless you want to. That's up to you, okay? So let's take a second and let's learn how to write vectors as a linear combination. It's really, really simple, okay? Here we go. Now I would write this next sentence in your notes. Not the whole thing, I guess, but this part right here. A vector cannot be written in linear combination unless it is first written in component form. So please don't forget that, okay? A vector cannot be written in linear combination unless it is first written in component form. After a vector is written in component form, it is quite easy to write it in linear combination. Okay, it's very easy actually. But you cannot write a vector as a linear combination unless it's first written in component form. So please keep that in mind, okay? So here we go. Let's go and start off with an example here. I want you to take this vector and I want you to write it as a linear combination, okay? This is really, really easy to do. Okay, so here we go. You ready for this? Okay, that's it. It's really simple. It's just another form of writing vectors, okay? Here we write the vectors with arrows. Here we're writing them as two terms, a linear combination, okay, using the letters I and J. Now, I'm not sure why they use the letters I and J, but those are the two letters that you use, okay? So whatever this number here is, always goes with I. Whatever this number here is, always goes with J, okay? So that's simple. Negative 2I plus 7J. Now let's continue on. I want you to take this vector here, vector CD, and I want you to write it as a linear combination. But remember what I had you write down up here earlier, students. A vector cannot be written in linear combination as a linear combination unless it is first written in component form. Okay? So this is your initial point. This is your terminal point. We must first write this in component form. So we take our terminal point minus our initial point, and we get out this for component form. 4, 2. There we go. So the first thing you do is you make sure your vector is written in component form. And now once you've done that, it's really easy to write it as a linear combination. 4I plus 2J. There we go. That's simple. Okay? Now go ahead and try this next one on your own. Okay? Go ahead and try this one on your own. Okay? I want you to write vector GH as a linear combination. Okay? I'm going to wait a second while you guys work on it. Let you guys get a head start on this. Don't forget, first of all, to write it in component form, and then once you've done that, it's very easy to write it as a linear combination. Okay, here we go. This is my initial point. Hopefully you guys are working ahead. Keep right on working, okay? So we take my terminal point minus my initial point, and my component form would be, let's see, negative 3 minus negative 6, that's 3. 2 minus 10, that's negative 8. So this component form, if you missed this, hopefully I didn't make a mistake anywhere. If you missed this, please find your mistake. And now we've written the component form vector as a linear combination, okay? So pretty simple to do. I'm teaching you guys a lot of stuff today that's really easy, but it's really, really important you know how to do this, and that you keep all of these terms in your mind, like dot product, unit vectors, linear combination, because you're going to have to know how to do this very quickly in certain situations later. Alright, okay, let's continue on. Now for these quick examples here, students, you'll probably feel like you're back in Algebra 1. I'm going to go really quick through these, okay, so take some really good notes. You can see they're very simple. We're adding and subtracting vectors. Only the vectors are in linear combination form, not component form, but it's still very easy, okay? U plus V, so U is 2I plus 3J plus V, which is negative 10I minus 3J. Okay, so your answer would be 2I plus negative 10, negative 8I, 3J plus negative 3J, 0J. And no, you do not have to put the 0J if you don't want to, okay? So you can put this for an answer, or you can put this for an answer, okay? So pretty simple. Okay, you can work ahead or watch me do the other ones, whatever you want to do. Here we go. 2 times u plus w. Okay, the first thing I would do is multiply my 2 through. So 4i plus 6j plus 8i, or excuse me, plus I plus 8j would equal 5i, because 4i plus 1i is 5i, and then 6j plus 8j would be 14. 14j. Okay, there we go. Pretty simple. And the last problem here, 2w minus 3v. So 2 times w minus 3, and v would be negative 10i minus 3j. Okay, so here we go. Take your 2 and multiply it through. 2i plus 16j. Take your negative 3 and multiply it through. Positive 30i, positive 9j, excuse me, and then combine like terms. So 2i plus 30i, 32i, 16j plus 9j, 25j. And there we go. Okay, just like that, pretty simple. Okay, so what we've done here is we've learned how to write vectors as a what? Linear combination. And remember, you must first write the vector in component form and then write it as a linear combination, okay? And then we're learning how to take those vectors written in linear combination form, and we can add them and subtract them pretty quickly and pretty easily, okay? All right, let's go ahead and move on. Okay, now let's look at something called finding direction, angles, and magnitude, okay? Finding direction, angles, and magnitude. Finding direction, angles, and finding magnitude. Okay, there's really no name for this. Just go ahead and write this down, okay? This is vector W. Go ahead and write this down. 6, and then a bracket, and then a parentheses, cosine of 150i plus sine of 150j. Now, this is another form of a vector. Just like so far, we've learned to write our vectors in a component form like this, and we've learned how to write our vectors as a linear combination with an I and a j. And there's also other ways you can write your vectors, and there's really no name for this form here, but you can use an angle and a length here. Okay, so just go ahead and copy this down, and let me show you what this means, okay? It simply means that your vector is 150 degrees over. So we start here and rotate 150 degrees. So there's your vector. And you see this number outside the bracket here? That's the length of your vector, 6. So there we go. It's that easy, okay? So there's your vector. They might say, Mr. Earhart, we don't know what the ordered pair is. True, but you can find that pretty easily. I mean, if we rotate 150 degrees, then we know we have 30 degrees left over here inside the triangle, correct? So we can very easily, by drawing a right triangle, see how far over we have to go to get my x, and how far up I have to go to get my y, okay? So sometimes, listen, sometimes vectors are written with ordered pairs, x and y, and sometimes they're written with just a direction, angle, and the magnitude. Okay, and by the way, you're going to find out later how helpful this form here can be. Okay, but anyways, what I'm asking you to do is to find the direction, angle, and the magnitude. Well, students, when it's written in this form here, it's so easy. What is your direction angle? 150 degrees. What is your magnitude? 6. Okay? So whenever it's written in this form here, it's pretty simple, okay? But let's make it a little more difficult now. What if I gave you a vector like this, okay? And I asked you to find the direction, angle, and the magnitude, okay? Well, the magnitude's easy. We can do that right away really quickly, okay? The magnitude would be 4 plus 64, okay? Square the 2, square the 8, add them together, and we get 68, okay? Now, we can actually simplify this very quickly. I think 4 times 17 is 68, and we know the square root of 4, so cross off the 4 and put a 2 on the outside, and so the magnitude would be 2 square root of 17. So that's pretty easy, okay? Now let's find the direction angle. Okay, students, now let's go ahead and find the direction angle of this vector right here, okay? So let's get a picture of it. This vector is over 2 and up 8. I'm just going to kind of estimate it. So there's my vector, and that's wrong, isn't it? Sorry about that. It's over 2 and then down 8. So that's good enough. There's my vector. Okay, now I want to find the direction angle that goes from here all the way to here, okay? Now, to me, it's pretty much common sense, and you guys, with all of your trig experience you've had the past weeks, you should see it's very easy to just go over to here and then go down to here and make a right triangle and label this side here what? 2, and this side here what? 8, and you could put, if you wanted to, the negative signs. That's not really a big deal right now. And now we're going to find this angle right here. And then once we know the angle there, we could easily find this whole angle here. Okay? So here we go. We have opposite and adjacent. So tangent of theta equals opposite over adjacent. Okay, so tangent of theta equals 4. Let me very quickly here grab my calculator. Hopefully I have it. And I do not see it. Okay, I found my calculator. So if I hit second tangent of 4, the angle I get is 75.96. So I'm going to go ahead and call this 76 degrees right here, okay? 76 degrees. So the direction angle would be 180 plus 76. Okay, so 180 plus 76, 256. Okay, so now that's all I asked you to do was simply find the direction angle, which you've done right here, and to find the magnitude, which you've done. However, if I asked you to write it in this form up here, you would simply put the magnitude outside. So 2 square root of 17, and put brackets, and then parentheses, and then cosine of your angle. So cosine of 256, I, then plus sign, then parentheses, sine of 256, J, and then close the bracket, okay? Now, I did not ask you to do that, but I'm just showing you how quickly you can write your vector in this form here if you wanted to, okay? But I asked you to find the magnitude and the direction angle, and we did that pretty easily, okay? So, not too bad. Now, let's go on to something else here. Let's look at finding the angles between two vectors. So if I give you two vectors, and they look maybe something like this, one vector going this direction, and one vector going maybe this direction here, okay? And I ask you to find the angle between the two vectors. Okay, let's look at how we're going to do that, okay? Alright, finding an angle between two vectors can be time consuming, okay? So watch carefully what I mean by that. Now you do not, if you don't want to, you do not have to take notes on what I'm about ready to show you right here. Okay, just watch this. If I ask you to find the angle between these two vectors here, first of all, you would have to graph them like this. Now, again, remember, don't take notes on this. Okay, I'm going to show you a really fast way to do this using a formula. Okay, but first of all, I want to show you how long it would be if we did not have this formula to use. Now, if I asked you to find the angle between these two vectors here, you would first of all have to graph it like this. Then next, you would have to draw a triangle here and find this angle here using tangent. Then you would have to draw a triangle here and using tangent to find the angle in here. Call it theta subscript 1. Okay? So you'd have to use tangent opposite over adjacent. Okay? And then once you found this angle here and this angle here, you'd have to add those two angles together. And then whatever you got out, you would have to subtract that from 180. We'll call this x. So you subtract it from 180 and finally get out the angle that's between these two vectors. Okay, that's a pretty, not horrible, but that's a pretty good time-consuming thing to do. Okay, so instead of doing it that way, there's a formula, thankfully, that we can use that allows us to find the angle between vectors pretty easily. Okay, so here's the formula. Please copy this down. The two vectors that you're using, we're going to call them u and v. You take the dot product of u and v, and then the denominator, you take the magnitude of u. Of course, in your book we have two lines, so put another line here. Magnitude of u times the magnitude of v. Okay? And then when you get all of this, you simplify all of that down to a number. You would then have cosine of theta equals that number, and then use second cosine on your calculator to get out the angle. Okay, now there's a proof of this, and I would love to do it for you, but it would make the video about 15 or 20 minutes longer, so I'm not going to go into the proof of where this formula comes from. Okay, but it's a really, really helpful formula. So with that in mind, let's take a look at 1, 2, 3 quick problems, and we're done for the whole video. Okay, so here we go. I want you to find the angle between these two vectors. Now you're welcome to work ahead if you feel like you totally understand this formula here, okay? Or you can stay with me, whatever you want to do. So here we go. First of all, for the numerator, we're going to take the dot product, u times v. We'll call this u. We'll call this v. We're going to take the dot product. So 3 times -4 is -12. 7 times 2 is 14. We're going to add them together and we'll get 2. So your numerator is 2, because the dot product of u and v is 2. Now, let's find the magnitude of u and the magnitude of v. Well, that's pretty easy to do. The magnitude of u would be square root of 9 plus 49, so the square root of 58. Okay? There we go. And then the magnitude of v would be 4 times 4 is 16, 2 times 2 is 4, so the square root of 20. So with a calculator, I'm going to go ahead and type square root of 58 times square root of 58 times square root of 20, and I will get 34.05877723, and then I'm going to take 2 divided by that number, and I'm going to get this decimal right here. This entire expression here equals 0.058723. 22022. Okay? Now remember, this entire expression right here equals cosine of theta. So this whole expression here equals cosine of theta. So now I'm going to hit second cosine on my calculator of this number, and I will get out 86.63 degrees. So I'm going to go ahead and put the angle between these two vectors is 86.6 degrees. That's it, guys. It's pretty simple, okay? I'm probably going to bore you by doing 3 of these, but I'd rather bore you than lose you, okay? So let's try another one. You can work ahead or watch me, okay? Let's find the angle between these two vectors here. I'm going to slide this up to get some room, slide this up, and here we go, okay? Well, first of all, for the top of the fraction, I'm going to take my dot product, u times v. So here's u, here's v, okay? Negative 3 times negative 5, 15. Negative 3 times 2, negative 6. Add those two numbers together, and we get a positive 9 up here, okay? Now, the magnitude of u. Well, the magnitude of u would be 3 times 3 is 9, 3 times 3 is 9. So the magnitude of u would be square root of 18. Okay? Now let's find the magnitude of v right here. Well, let's see. 25, square root of the 2, that would be 4. So the square root of 29. Okay? So there we go. So I'm going to go ahead and type this fraction into my calculator. And you can do that however you want to. Just make sure you get it correct. And I'm getting this right here. Hopefully this is correct. 3939192,986. And then second cosine of that number. And we'll have this for an angle. Theta equals 66.80. So 66.8 degrees. Okay? And one more and we're finally finished. Okay? Done with the whole video. So here we go. Okay, here we go. Cosine of theta, we'll go really fast now. You can work ahead or watch me. Cosine of theta, here we go. U times v. Negative 4 times 1 is negative 4. 2 times negative 4 is negative 8. Add those two numbers together, negative 12. So there we go. Okay, there's the dot product. Now let's find the magnitude of u. Square root of the 4, that's 16. Square root of the 2, that's 4. Square root of 20. Okay, going pretty fast now, pretty simple. Magnitude of v, square root of the 1, square root of the 4, add them together, square root of 17. Okay, so now if you're having a hard time getting out the correct decimal right here and right here, let me tell you how I'm typing this into my calculator. I'm typing into my calculator square root of 20, then I hit enter, then times square root of 17, then enter again. Okay, so what I have now is negative 12 over 18.43908891. Okay, now if I type that in my calculator, I will get this right here. And don't forget your negative sign. A negative divided by a positive is a negative point. And Mr. Earhart, is negative a big deal? Yes, that's a very big deal. That's going to totally change your angle, okay? So there we go, something like this. Hit second cosine of that number. and you'll get 49.39. 49.39. So I'm going to put 49.4 degrees. Okay? Oh, actually, I did that wrong, and I apologize, guys. Hold on 1 second, please. Your old teacher made a mistake there, so hold on 1 second. Second cosine. After all my lecturing, you guys do not forget your negative sign. I totally forgot my negative sign. Alright, let's see if we can do this here. Alright, there we go. There we go, 130. I'm getting 130.60. So 130.6 degrees. Okay, sorry about that. So there we go. So very, very quickly, and I do mean extremely quickly. Let's do this, okay? Okay, let's review. First of all, you should be able to find the dot product of two vectors, okay? Next, you should be able to find a unit vector. You should know what a unit vector is and be able to find a unit vector going a certain direction, okay? You should be able to write a vector as a linear combination like this. And you should also be able to take linear combination vectors like this and simplify them. You should be able to find direction angles and magnitude of vectors. And lastly, you should be able to find angles between vectors, okay? And that's it for today, guys. Hopefully this video has been a help to you. If you have any questions, don't hesitate to call or email.